What if I told you that right now, something is happening in our solar system that might rewrite what we think we know about interstellar visitors? Imagine an object from deep space that refuses to behave like anything nature has ever shown us. On November 5, 2025, the Virtual Telescope Project released two new images of the interstellar traveler known as 3I Atlas, and what they revealed has scientists completely baffled. The object appears as a tight, concentrated point of light. No trace of the shimmering tail you'd expect from a comet approaching the sun. Even more incredible, it looks almost identical to how it appeared months earlier in July 2025. When Hubble first captured it, Harvard astrophysicist Avi Loeb ran the numbers, and they don't make sense. By this point, Atlas should have lost at least 13% of its total mass. That's more than 5.5 billion tons of material. But there's no visible cloud, no coma, no trace of what should have been an enormous plume of gas and dust. To make that absence even stranger, those same images caught another comet, Lemon, glowing exactly as a normal comet should, bright, with a clear tail stretching away from the sun under radiation pressure. Atlas, in contrast, remains eerily clean. For Loeb, this is more than an oddity. It's another piece of evidence that Atlas simply isn't acting like a natural comet. That raises a question few in science are comfortable asking. What exactly are we looking at? There's been plenty of speculation, panic, and misinformation about Atlas's acceleration. So in this analysis, we'll break down the real data to find out whether we're witnessing something extraordinary, moving through our solar system, or if physics still has an explanation, hiding somewhere in the numbers. On October 29th, right at its closest pass to the sun, Atlas began accelerating in a way that gravity alone can't explain. NASA's Jet Propulsion Laboratory confirmed it's now 4 arcseconds off from where it should be if only gravity were acting on it. That might sound tiny, but when you're talking about something more than 200 million kilometers away, that offset is enormous. The acceleration measures around 0.02 millimeters per second squared. Over a month, that gentle push shifted Atlas roughly 80,000 kilometers from its expected trajectory. It isn't just one push either. The acceleration has two distinct components. One away from the sun, about 135 kilometers per day squared, giving roughly 60,000 kilometers of drift each month. The other is lateral, about 60 kilometers per day squared, or 27,000 kilometers of sideways motion. In other words, Atlas is being nudged outward and sideways simultaneously, as if something invisible were steering it ever so slightly. Before anyone panics, this doesn't mean it's headed toward Earth. Its deviation isn't enough to alter its course toward any planet except Jupiter, which it's projected to reach in March 2026. So what does non-gravitational acceleration really mean? Think of it like this. If you toss a ball, gravity determines exactly how it falls. But if that ball had tiny thrusters firing from its sides, it would drift off the expected path. That's what we're seeing. Atlas is moving as though some additional force, beyond gravity, is pushing it along. For comets, the usual explanation is outgassing. When solar heat turns surface ice into gas, it acts like a mini rocket engine. That's perfectly normal. But here's the problem. The amount of gas Atlas would need to release to produce this acceleration is staggering. Loeb did the math. Based on its size and motion, the object's mass is at least 33 billion tons, far larger than the previous interstellar objects, Oumuamua or Borisov, by up to 1 million times. Its solid core is estimated around 3.5 miles, nearly 6 kilometers wide. For something that massive to move this way, it would need to shed at least 1/16 of its total weight during its closest pass to the Sun, over 5.5 billion tons of material. That much gas would create a vast, brilliant halo, a coma visible even to smaller observatories. It would be impossible to miss. Yet the skies remain silent and clean. Between late November 2025 and the end of January 2026, some of the world's most powerful telescopes, Hubble, James Webb, and dozens more, will focus on Atlas. On December 19th, it'll make its nearest approach to Earth, about 167 million miles away. If that colossal cloud exists, it will light up the data. But if it doesn't, then the accepted explanation collapses. No visible gas means no natural propulsion. And if it isn't natural, then we're forced to confront the unsettling alternative, that the acceleration might come from something technological. We've seen this pattern before. When Oumuamua passed through, it too accelerated without any sign of dust or gas. Even the ultra-sensitive Spitzer Space Telescope couldn't detect outgassing. Scientists labeled it a dark comet, though that phrase contradicts itself, a comet defined by having no visible tail. Now Atlas is repeating that mystery, but with additional twists that make natural explanations even harder to justify. The first clue lies in brightness. As Atlas drew closer to the Sun, its luminosity increased following a power law of 7.5. For comparison, normal comets brighten between 2 and 3. Atlas is more than twice as reactive, brightening at a rate beyond any previously observed comet. It's an anomaly with no precedent. The second clue, the 9th on the list of strange behaviors, is its color. Atlas appears bluer than the Sun itself near perihelion. That's astonishing. Dust tends to scatter red light, making most comets appear warmer in tone, not colder. Atlas's surface temperature should be roughly 20 times lower than the Sun's, which means it should glow reddish, not blue. So what's causing this? One theory points to ionized gases like carbon dioxide, which can emit blue light directly, but that still doesn't explain the consistency of its hue across different instruments and filters. Now let's be clear. No credible scientist is jumping to call Atlas alien. The real discussion is about how science handles contradictions. When the data refuses to fit, you don't reject the data. You question the theory. Yet some astronomers dismiss the measurements outright because they didn't align with existing models. Avi Loeb challenged that, saying that's not how science is supposed to work. You can't deny results just because they make you uncomfortable. Atlas isn't merely another rock drifting through space. It's a singular event in modern astronomy, pushing at the limits of what we think we understand about physics and cosmic formation. And the deeper we look, the stranger it becomes. Atlas is a singular object in our solar system, not just for what it shows us, but for what it forces us to reconsider. Every detail adds to a growing list of anomalies that make less and less sense under the lens of ordinary physics. The first is its impossible path. Atlas is traveling along a line only 5 degrees from the ecliptic plane, the same flat, invisible sheet where all our planets orbit the Sun. If you picture the solar system as marbles rolling on a smooth tabletop, every planet moves on that same level surface. An object entering from another star system should come from any direction, above, below, even sideways. Yet Atlas arrived nearly perfectly aligned with that tabletop. The odds of such precision happening by chance are roughly 2 in 1,000, like hitting a bullseye in the dark. Then comes the jet that defies physics. During July and August 2025, Atlas released a narrow stream of material pointed directly toward the sun. That's the opposite of what any natural comet does. Radiation from the sun always pushes dust and gas away, forming tails that stretch outward like hair blown by wind. But Atlas broke that fundamental rule. Its material shot toward the source of radiation, as if the laws of motion themselves had been reversed. Next is its sheer scale and velocity. Atlas is 1,000,000 times heavier than Oumuamua and 1,000 times more massive than Borisov, yet somehow it's moving faster. Imagine a loaded cargo truck overtaking race cars on a highway. Large bodies are supposed to move slower because gravity tugs harder on massive objects ejected from their home systems. But here the giant is speeding past the small. Probability alone can't explain that. Timing adds another layer. Atlas managed to approach Mars, Venus, and Jupiter at almost mathematically perfect intervals. Yet during its most critical moment, its closest pass to the sun, it stayed completely hidden from Earth's direct view. It's like a traveler visiting 3 capital cities but avoiding every camera at the main airport. That degree of orbital choreography feels deliberate. The odds of it occurring naturally slimmer than winning multiple lotteries in a row. Then there's what scientists call the factory composition. Spectral analysis shows Atlas contains far more nickel than iron, a ratio characteristic of refined metallic alloys, materials that, on Earth, are typically produced, not found. Natural comets usually show a chaotic mix of metals, random and uneven. But Atlas displays a precise recipe, like something engineered rather than born from cosmic debris. Another contradiction, it's nearly bone dry. Traditional comets are dirty snowballs made of mostly frozen water and dust. Atlas has barely 4% water content, drier than the Sahara. It's like discovering an iceberg that's almost pure stone. That difference alone challenges what a comet even is. Light from Atlas also behaves unlike any known body. The way it polarizes, how the light waves align after reflecting off its surface, doesn't match any cataloged object in nature. Every surface leaves a kind of optical fingerprint. But Atlas's fingerprint isn't found anywhere, not even in data from Borisov or any solar system comet. And perhaps the most chilling connection, Atlas entered from nearly the same direction as the mysterious WOW signal of 1977, the unexplained radio burst many still consider potential evidence of extraterrestrial origin. 2 cosmic events half a century apart pointing toward the same patch of sky. The statistical chance of that is vanishingly small. Finally, there's the temperature puzzle. Atlas glows bluer than our own star, implying a heat source even more intense than the sun's surface, which burns at 5,800 Kelvin. That would mean something inside it generates or reflects energy beyond any known natural process, as though a small object were radiating power greater than a star. Physics leaves us no easy escape. Such acceleration would require enormous mass loss, yet no cloud or dust halo is seen. If those 5.5 billion tons of gas don't appear when Atlas makes its closest approach to Earth on December 19, 2025, the natural explanation collapses completely. Hundreds of telescopes will be watching, searching the void for the missing material. And if nothing is found, then we'll be forced to accept what the data has been whispering all along, that we may not be observing a comet at all. We may be watching technology built elsewhere demonstrating a propulsion system beyond human comprehension. The countdown has already begun. In a few short weeks, we'll know whether Atlas is simply another visitor from the stars or the first undeniable sign that something, or someone, is deliberately watching us from the dark between worlds.